Another way to control exposure is using ISO. Is an abbreviation for International Standards Organization. This was a standard that was used with film, and it replaced an older standard called ASA, American Standards Association, which morphed into the American National Standards Institute. In Germany, they use another standard called DIN, Deutsche Industry Norm. One of the reasons they probably went to an ISO standard is originally Kodak was dominant and they used the ASA standard. But then Fujifilm, Konica Film, and other film companies became more popular, and of course Agfa Film in Germany. So that's how we ended up with all these different standards for film sensitivity. So, in order to get the ISO number, people in the laboratories would use a special test, a standardized test from ISO that no matter what film company you're working for, Fuji, Kodak, Agfa, you'd use the same test to show the sensitivity of the film to light. And then they would express that number they came up with, that they calculated as 100 over 20 or 400 over. So the first number was the ISO number, and the second one was a DIN number. These are common ISOs that you would get with film, and as the film speed goes up, the sensitivity of the film to light increases. And most of these would double. So like Fujifilm used to have film speeds of 50, 100, 200, 400, 800, 1600. So each one would double, would be like going up one stop faster on the aperture, or a longer or a shorter shutter speed. Digital cameras have a broad range of ISOs, much broader than film. And these are, again, actually indications of the sensor sensitivity to light. They're not actually using that old film ISO standard, but it gives you an equivalent that people that were switching from film to digital understood. Cameras have an optimum ISO, for example, 100, and they also have an optimum range of ISOs. But they can go from very high ISOs to very low light, for low light photography, or very small ISOs for bright light photography. If you're using film, it's really important to set the ISO correctly to get the right exposure. And you can also set the ISO on digital cameras based on whether you want to emphasize your shutter speed or your aperture. And we'll talk more about why you would do that later. So digital cameras have a default sensitivity and a native sensitivity range. So for example, this camera has a default of 100. So if you set it at 100, it's probably the highest quality you can get. But the range of really good quality on that camera is from 100 to 12,800. But it will even go beyond that using an extended range of 50 up to 102,400. When you go outside the native range, your quality may not be quite as good, but it would probably produce an acceptable photograph, especially if you're putting it on the internet. This is what happens when you go outside the range to a very high ISO. When I was shooting my son, when he used to play polo, scholastic polo in arenas, the light wasn't that great, and I would have to use a high shutter speed, and the only way I could do it is to boost up to a very high ISO. That was grainy, but today with software like Lightroom Classic AI Enhance, you can eliminate a lot of that grain. Here's a close-up to show you the difference between the grain and that came out of the camera and what it looks like after you enhance it. Now, film would also give you this grainy effect. If you used, say, a 1600 or even 3200 film, it would be a lot grainier than a slow film like ISO 50. Again, this is what using a really high-speed film might look like, or a very high ISO on your digital camera that's outside the native range. But again, you can go into a software and do a lot of correction with it. So, why do you need different ISOs? There's only one correct exposure for a film or a sensor, and if you only had one choice of ISO, you would be limited to these kinds of f-stops and shutter speeds. So if you wanted to use a 500th of a second, you would have to use f8. If you wanted to use f22, you'd have to use a 60th of a second. But a 60th might be too slow for some uses with some lenses, and you would want to change your ISO. And we'll talk more about that in the next series. So, for example, if you wanted a fast shutter speed and a small aperture opening, you could use a speed like 400, and now you could do f22 at a 250th or a 16th of it at a 500th. And here's another setting, ISO 50, which would give you with fine grain with film, but would be out of the range of a lot of digital cameras. But anyway, it would give you the ability to shoot slower shutter speeds. And we'll talk about why you'd want to do that. If you've ever been to the ophthalmologist, or they'll put drops in your eyes and dilate the pupil, which is fine until you go outside and you'll have to wear sunglasses to drive home. Sometimes they'll even give you a cheap pair of sunglasses if you didn't bring your own. Same thing happens with ISO. For example, on the digital camera I showed you, the native ISO was 100. You could drop it down to 50. It would not be optimum. So if you wanted to get an even longer exposure, you'd have to use something called a neutral density filter. And it works the same way sunglasses work with your dilated pupils in your eye. It just blocks light from entering. Neutral density filters come in a lot of different strengths, and they change by one stops. As you can see, if you go from a neutral density 2, it's a 2x, one stop, less light. So if you were at 100, you could go down to 50. With a ND4, you could go down to 25. With an ND8, your ISO would now be 12 and a half, as you can see the series. So that's your f-stop reduction. The optical density shows the transmission differences, and you may note that the optical densities are log numbers, 0.3, 0.6, 0.9. If you look at the bottom of the chart, you'll see some very strong neutral density filters, and you may wonder why you'd want to use one of those. Well, here's an example. If you were trying to photograph an eclipse, you would want to use at least an ND 1024 that gives you 10% of the light that you would get it with the lowest ISO you could use on your camera. And you can even go to ND 10,000 that would give you a 1% difference. By the way, if you photograph eclipses, you have to use a neutral density filter. You never want to point your camera lens at the sun, because it could really damage the sensor. So keep that in mind if you're doing eclipses or just taking regular photography. Try not to point your camera directly at the sun. A lot of cameras, film cameras, came out with a way of automatically reading the ISO, so you wouldn't forget to set it. And with digital cameras, there's often a setting that will automatically change the ISO. So if you wanted to use a combination of f-stops and shutter speeds that wouldn't work with, say, ISO 100, it can drop it down to 50 automatically or go up to 200 automatically. You have to keep an eye on that, though, because it may go to a ISO that's out of the range that you want to work at.